Okay, good afternoon, folks. Just let me know that the image and the sound are okay. Just 1%. If you can hear me and see the image good. Good. Thanks, Trace. All right. Uh, let's get started. I just want to remind you that, again, there are two things actually I should remind you. One is about the Excel that I'm going to put next. Excel probably tonight or tomorrow, and it's going to be due a week from tonight to today, Wednesday. So it's going to be, you have to do it by next Wednesday. And this Excel assignment is optional. If you don't do it, you won't lose any point. If you do it and your grade is better than your lowest score, lowest grade on Excel assignment, it's going to replace that. So in that sense, if you missed an assignment, or I got a few, I mean, not a few, a lot of emails at the beginning that students were late to submit their assignments, few minutes, few hours, few days, and they had a lot of, other problems. So I thought that if I make extra assignment and make it optional for those of you who have missed uh, submitting one assignment, so that will take care of that problem, okay? And it's going to be due, I want to make it due before the finals week. So that's going to be either just read the date carefully on the assignment. It's going to be either, most likely it's going to be Wednesday night by 11:59. Let's just do it right now, 11:59 next Wednesday. Today is March 7, it will be March 13 by 11:59, and that's going to be optional. If you don't do it, don't worry about it, and this would be your last assignment, but the one that you're going to submit, assignment 7, I suppose. I got an email from the administration that asking me to remind you there is going to be feedback evaluation thing that you have to do, and you need to do that. What do you mean, what is that again? Again, what? Abby, what are you asking? What is that again? What is the assignment due next Wednesday? The assignment that I'm going to assign it today, it's going to be due next Wednesday, and that's your last assignment. But the last assignment, it's going to be optional assignment. If you don't do it, you won't lose any points. That's it. Is that clear? Yes? No? Okay. So another way of saying it, your last assignment, assignment number 7, that is extra one that I'm going to put it. I don't call it extra credit because some people are going to work and it's going to replace their lowest score assignment. So I call it optional. It's a win-win situation. If you don't do it, you won't lose any points. And if you do it and it's better than your lowest grade, you gain something. That's all. Given the fact that I think it's 15 points assigned for the Excel assignment, so that means each Excel assignment is worth 2.1 points towards your final grade. If you think that you got the two lowest score, you're better off to do the optional assignment and bring up your grade. And did I mention about the feedback or evaluation? Yeah, you should do that because we got an email. We have to remind you. And one of the things that I've heard that if you fill out the form, so you have access to your grades the minute I enter the grades in the DuckWeb. I can't verify the veracity of this claim, but I've heard it from students. That is the case. I don't know if it's true or not. But so your exam is going to be on Monday. Most likely your grades will be in on the finals week. So if you want to have access to your grade, it's a good thing to fill out the form. But if you don't care about these things, you want to wait a week or two and get your grades, that's a different story. It's totally up to you. This is the thing that we got an email, we have to convey the message. Okay, Excel 7, isn't it the option? No, Excel, the one that you have to submit, it's this coming Monday. That's mandatory. You have to submit it. If you don't, you're going to lose a point. This coming Monday, you got to submit your Excel assignment. There will be another one, we call it number 8, and that would be optional, and that will be assigned probably tonight. I will, yeah, okay. Are we okay with the Excel assignments? Any questions? Good. So your mandatory Excel assignment, it's due this coming Monday. After that, there's going to be another Excel assignment. We call it optional, and that is due next Wednesday, March 13th. All right. So we are on chapter 23 and comparing two proportions. This chapter is important because your Excel assignment is partially based on this chapter, partially. So we went through this. This is similar to what we had before when we talked about two means, comparing two means. Now we are comparing two proportions. So we looked at the proportions. We went through this before. So again, you have proportions. That's a population. It doesn't have a hat on them, and they don't have hat. This one is sample proportion, and that's a sample size. Group 1 and 2, oops. Group 1 and 2, this is the sample proportions, this is population proportions, and those are the sample sizes. And we talked about this before. This was when we dealt with two means. Two means, two sample means, and we had mu1 and mu2, but here we have p1 and p2. Here we had x bar 1 and x bar 2. Here we have proportions, sample proportions. That's a difference. There is this similar, that you do the same thing, similar. So in the case of two means, because we could calculate the standard deviation from the samples, it was easy to do it. We did it. But in this case, you need to find a proportion. So proportion, when you find proportion, we have two cases. Either it failed or succeeded. Number of successes and number of failures. So we have to include both. This is number of successes, and 1 minus P1 hat, that's number of failures. So multiplication of that gives you similar to the S12 in the two means problems. And this is group 2. Again, the definition of P1, number of successes divided by sample size, number of successes of group 2 divided by sample size. We went all the way there. That was a review. Now let's do this problem. All right. In a sample of 234 individuals over the age of 25, chosen at random from the state of Oregon, 48 did not have high school diploma. So let's say group 1, that would be Oregon. And so what do we have? Sample size N is 234, and number of successes is 48. Okay. And then we have group 2. That would be California. And what do we have there? A similar random sample in California finds 72 out of 378. So this is N1. And this would be N2, and that would be 387. And number of successes, that would be 72. That's group 2. Okay. So here, number of failures would be 1 minus, not 1, I'm sorry, 234 minus 48. And if you subtract that, it becomes 186. In this case, number of failures for California, it would be 387 minus 72, and that would be 315. Okay. All right, verified. Okay, we have this and individuals. We calculate. Now let's see what the question is. Verified that the conditions for a large sample confidence interval are met in comparing the difference between the two states in proportion of individuals who do not have a high school degree. Okay, is this a large sample? What are the criteria for large sample confidence interval? We know that the number of failures and number of successes must be greater than or equal to 1. I mean 10. 1. Oh my God. 10. It should be greater than or equal to 10. Also, we have to have SRS. Also, we have to have large sample. The sample size should be greater. So for group 1, what do we have? We have number of successes. It's 48, which is greater than or equal to 10. Check mark. Number of failures, which is 186, greater than or equal to 10. Sample size N, SRS, great. That's check mark 2. For group 2, we got to do the same thing. For group 2, number of successes is 72. 72 is greater than or equal to 10, check mark. Number of failures, and that is 315, greater than 10, check mark. And its SRS, and this is N2, is 387, large enough. So therefore, we say, yes, you can use a large sample confidence interval. Okay. What happened to my pencil? Okay, let's do the part B. Problem B is we have give the 96% large sample confidence interval and for the difference in proportion of individuals between the states. So let's see. If you want to write confidence interval for large sample is, if you go look at it, it's look at the previous pages for P1 minus P2 plus or minus Z star square root of P1 1 minus P2 divided by N1 plus P2 hat times 1 minus P2 hat divided by N2. That is the definition. I think we have it here. It's from the first page. We got it from the first page. Okay. Now let's look at it for group 1. Let's see what is P1 hat. That would be number of successes. divided by sample size. And that would be number of successes would be, we had it 48. Sample size is, there's a sample 234. 234. And for group 2, we had 2. That would be number of successes again. This is group 1. Group 2 divided by sample size. N2 is N1. And that would be 72 divided by 387. So those are P1 and P2. We already got that. And what is the confidence? Confidence level is 96%. 96% gives me Z star value to be 2.054. Does anyone want to see that how I get this Z star? If you want to see it, just one person say yes, then I will go through it. Otherwise, I'm not going to go. Yes? Okay. All right. Here what we have. 96%. 96% is, you got to look at this value. Here on the top, you look at this 96, this is 96%, right? So I'm going to use this one here to block the rest of them here. That is a column for 96%, right? All the way, you're going to come down, and then you're going to look at the Z. That is the Z star. You see this number there, 2.054, and that is the 96%. All right? So that's 2.054. So the Z star would be 2.054. That's the value we have. Okay. The rest is just to plug the numbers, see what we get. Confidence interval would be P1 minus P2. P1 is 48 over 234 minus 72 over 387 plus and minus. Z star is 2.054. And you have square root of, just put the numbers there. P1 is 48 over 234. 1 minus 48 over 234. And the size of that is N1 is 234 plus, and then you do it for group 2. For group 2 is P2 minus times 1 minus P2. That would be 72 over 387. 1 minus 72 over 387. And the size of sample for this is 387. Okay? Just put it in your calculator and calculate the whole thing. And I'm going to do the approximate value of these. 72, I have it here, plus or minus 2.054. And we have 2.51. 1 minus 0.2051 divided by 234 plus 0, 1 minus 0 divided by 387. So just subtract this, multiply that, divide it by that, add them up, take square root of that, and multiply it by 2.054. And the eventual number is, the final is, you have I have, what is the number? Do I have it? Let me see. Notes. Yeah. So the number is problem one. We are working on problem one. That is point minus 0.0486 0.08684. That would be the confidence interval. All right. Questions? Are we okay with that? Okay. Let's move on to the next problem. Next problem is you're gonna use this in your Excel program. Problem possible. I think it's problem number 2, and you use the pooled sample proportion there. You're gonna use it there. But anyhow, let's look at the definition of significance test. So far, we dealt with confidence interval for 2 sample proportions. Now we are doing significance test for 2 sample proportions. So we have to do with the hypothesis, null hypothesis and alternative hypothesis. So this is for the difference. Again, we are looking at the difference. It's exactly similar to what we did for the two means. Remember, in the 2 means, H0 we defined that to be mu. We had a mu1 equal to mu2, or another way of saying it, mu1 minus mu2 was 0 equal to 0. For alternative, we had either 3 cases: mu1 greater than mu2, or we said mu1 minus mu2 greater than 0, mu1 less than mu2, that means mu1 minus mu2 less than 0, and the last one was mu1 not equal to mu2, and that was mu1 minus mu2 not equal to 0. We did this, and if you go back to your 2 means, two sample means that you look at it, we have those. So we are going to just copy this, exactly the same thing, replace mu1 with p1 and mu2 with the p2, right? Remember, I just wanted to remind you again, anytime when you do the null hypothesis, you do not use any elements of samples in the description for the null hypothesis and alternative. All these things over here, they are population parameters. In this case, they are population means. In this case, it's going to be population proportions. So here, if I want to write this again, so H0 would be, basically we're looking at P1 equal to P2, or we can say P1 minus P2 equal to 0. And the alternative hypothesis could be P1 greater than P2, or we can say P1 minus P2 greater than 0, P1 less than P2, that means P1 minus P2 less than 0, or P1 not equal to P2, that would be P1 minus P2 not equal to 0. And this is for the proportion we write. This part is we use only population parameters. Okay, like every time when we wanted to calculate the null hypothesis, we wanted to know either z test, z statistic, or t. In this case, since we are dealing with z, we have to find the value of z. The value of z is, again, this time this is the difference between sample proportions. P1 hat minus P2 hat. This is the sample proportions. And for z statistics, so we have P hat 1 minus P hat. There is no subscript here. And this is what we call it pooled sample. the combination of both of them. Multiply 1 over n1 plus 1 over n2. Here's the definition of p hat. Again, this is not, has nothing to do with the population. It is this mean. It is a part of the sample, but we call it pooled. And the definition of its pooled sample proportion. And the definition is you add two number of successes divided by the total number of both sample sizes. So in this case, that would be number of successes in the first sample plus number of successes in the second sample divided by the sample size of group 1 plus sample size of group 2. You add them up. And the conditions for this that you can use this is if it starts minimum value of the successes and failures must be 5. So 5 or greater. The test is valid only for both samples, SRS, and the counts of successes and failures are 5 or greater than that. Okay, this is the condition. This should be case and SRS. Okay, let's do a problem on this one. Exercise number 2. The curse of the pharaohs is the notion that when an individual opens the tomb of an Egyptian pharaoh, they will die soon after. When opening the tomb of famous King Tut is easier to say. King Tut, there were approximately 40 people present. Within the next 10 years, 6 of them had died. In a random sample of 60 individuals from around the world, 55 were still living 10 years later. Okay, at 5% significance level, is there evidence of a higher ratio of deaths in those who open the pharaoh's tomb as compared to the general population? Okay, so if we want to do this, so we got to calculate to see what the values are. So I'm going to say H0 is assuming that P1 is the same as P2. Okay, so this would be the death rate in general population and this would be the death rate. Oh no, sorry, that's not that one. And this would be this P1 would be this is P2 for that one. Death rate, we calculate death rate from openers, or I guess. Okay. So that is H0. So we are comparing those two. General population, what did we have here? For general, we have 60 individuals, 5 of them died, 55 are still alive. That would be general. For tomb openers, there were 40 of them, 10 of them died after 10 years. That's the case. So we are comparing those two. So, and here it says the higher ratio deaths in those who open the pharaoh's tomb as compared to them. So therefore, alternative hypothesis, since this is the P1 for the pharaoh's tomb openers, so we want to say if it's higher than the general population death rate. So if we want to do that, I'm going to call it group 1 is going to be tomb openers. So it's going to be basically, I'm going to say N1, and that would be 40 number of tomb openers. Tomb. Openers have, opener is 1N, isn't it? I think. I don't know. Can't remember. Okay. Group of 2. N2 is 60. Openers, and this is general population. Okay. Now, group 1 successes. It's kind of morbid to call them the death rate successes. The number of successes, I already wrote that. Number of successes is 6. And group 2, number of successes is 5. Is it 5? Yeah, 50. There was 60, 55 of them are still alive. And the first one was 40, 6 of them died. That's right, 6 and 5. Okay, so if I wanna, you can see this matches with what we have here for pooled uh, um, for pooled sample proportion. Remember, this is NP greater than or equal to 5, and in this case, n times minus p hat is greater than or equal to 5. This matches exactly what we have there when we write it. So therefore, if I want to write, this is group 1 again, so I'm going to say P1 hat. Now we are looking at the proportion. Proportion number of successes we have here divided by sample size, and that would be for group 1 is 6, and the number of tomb openers are 40. For group 2, P hat 2, again the same thing, and then you have here 5, total number is 60. Now, if you want to calculate pooled sample population, which we call the P hat, this is pooled sample population, and this is equal to number of successes of group 1 plus number of successes of group 2 divided by N1 plus N2. So therefore, P hat would be equal to 6 plus 5 divided by 40 plus 60. And that would be 11 over 100. That is the P hat. Now we have to, so we have P hat. If you look at the formula, I have P1 hat, P2 hat, P hat, N1, N2, so I can calculate Z now. The minute I get the value of Z, I can calculate the P value. So therefore, I don't have enough room here. Maybe I should do it this way. the definition of z is equal to p1 hat minus p2 hat divided by square root of p hat 1 minus p hat times 1 over n1 plus 1 over n2. So therefore, I'm going to put the values there. Z is equal to P1 hat is 60 over 40 minus P2 hat is 5 over 60. Put a parentheses around it. And then P hat is 11 over 100. 1 minus 11 over 100 times 1 over N1. Size of N1 is 140 plus 1 over 60. That would be the Z value. And based on my calculation, I came up with the number 1.04. If you do this, put it in your calculator or Excel or even Google, you can get that number. If you type this, you get that number. Okay, now if you want to calculate the p-value, what is it here? We have this greater than p1 greater than p2, right? So the p, since this is a greater than that, so if I write p, so z must be greater than this value, greater than 1.04. But when you look at the table, you have, the table is only written for z less than 1.04. So you got to convert this one 1 minus p of z less than 1.04. So that would be equal to 1 minus. All right, let's do this again one more time. You have z is what is it? 1.04. Okay, let's look at it. Here is, now you're looking at the A table. 1 point. This is 1.04 would be this one. You go look at it, this is 04. So that would be 1.04. That would be 0.8508. It's 0.8508. If you subtract that, that would be what? 2, 1, 4, 1, 0. This should be 9, isn't it? So that would be the value. Now, if you look at this one, this means what? 14.92%, right? This is 1.492, and let's beautify this a little bit. So that is the value. This is 14.92%. So you can see that 14.92% is greater than, we have 5% here, because they are asking me at 5% significance level. So this is greater than 5%. So we failed to reject null hypothesis. Therefore, the death rates are the same. It doesn't matter what you have here. There is no difference whether you're part of the population or no difference. Or you open the tomb of Pharaoh. So that's a superstitious, basically. That's what it says. Science says that that cannot happen. All right. Are we okay with this? Any questions? You saw how I used the pooled sample proportion. I think you're going to use this one in Excel 7, number 7, the one that you're going to turn it in this coming Monday. So you're going to use it there. Okay. The last page of the last chapter. Okay. Now let's look at this. what we have here, it says, are the conditions met for a large sample confidence interval on the difference in death rates? Okay, so let's look at it. What did we have here? What was the number of successes? Number of successes, group 1. How many was it? It was 6, which is less than 10. No, didn't meet that criteria. It was supposed to be greater than that. Again, number of successes of group 2 is 5, less than 10. No, it didn't. So therefore, cannot use large sample method. All right. Okay, let's move on. There's another topic that you're gonna see here. Again, +4 is back here. We're gonna look at this one more time. It says a large sample confidence interval for P1 minus P2, just like for P, is fairly unreliable. We said that it was unreliable, unless the sample size was huge, big. Unless the sample sizes and population sizes are very large. So if it's not large, so we use a +4, it's more reliable. The +4 confidence interval for P1 minus P2 can be used even given 2 SRSs when N1 greater than and N2 greater than 5, greater than or equal to 5. It's obtained by adding one imaginary success and one imaginary failure to each one. Remember in +4, when we had +4 for one sample, so what we had there, we added number of successes +2 divided by sample size, N +4. But you had a failure too. Number of failures +2 divided by 4. You see that at 2 plus 2 is 4 is the same as, oh, this is N +4. So you added those 4 that in the sample size, which is here, you split it. Half goes to successes and the other half goes to the failures. But here you have 2 samples. So therefore, if you take 4 and split it, you have to go 4 ways, because one is going to go to the successes of group of 1, failure of group of 1 takes another one, then successes of group 2 takes another one, and successes of group 2 takes another one. So 1 is going to be added to each one. But then you have 4. 4, because of the 2 samples, each sample takes 2 units of 4. And that is the reason you see N1 plus 2 here, N2 plus 2 here. And these P1 and P2 that when you calculate here, we have to look at this one, P hat, P tilde, number of successes in the first sample +1 and divided by +2. Number of failures, number of successes in second sample +1, because you have a similar situation for failures here, +1 divided by N1 plus 2. And the same thing here, failures +1, N2 plus 2. So if you add 1 plus 1 plus 1 plus 1, that's 4. It's going to be the same as 2 plus 2, which is 4. But this is for 2 samples. For one sample was a little bit different. All right? Okay, let's just do this problem now. Find the +4 confidence interval at 95% level of the difference in the death rates from example 2. Okay, we got to do that now. With the information we had, look at the information here. So we are going to use, first of all, I want to find P1 tilde. P1 tilde would be, I have number of successes plus 1 divided by sample size plus 2. Number of successes in the first case, we had 6 plus 1. And number of samples we had there, 40 plus 2. That would be 7 divided by 42. And that would be 1 over 6, I think. So for the other one, we have P2 tilde. Again, number of successes plus 1 divided by sample size plus 2. Number of successes in the second case is 5 plus 1, and that was 60 plus 2. That would be 60 divided by 62. So we have these values, and again, the value of Z star for 95% confidence interval would be, for 95%, would give you Z star is equal to 1.96. This is from table C. Okay, so plug them back in the equations that we had. This is the equation we have here, right? I brought this equation down here. So basically it says P1 hat tilde minus P2 tilde plus and minus Z star. And we have P1 tilde 1 minus P1 tilde divided by N1 plus 2 plus P2 tilde P2 tilde divided by N2 plus 2. We're going to plug it in this formula, and that would be confidence interval. So confidence interval would be P1 is 1 over 6 plus 6 minus 6 over 62 plus or minus Z star is 1.96. Again, P1 tilde, we calculated it's 1 over 6, 1 minus 1 over 6. Total number is 40 plus 2 plus P2 is 6 over 62, 1 minus 6 over 62, divided by N2 is 60 plus 2. To simplify this, when you simplify, CI becomes minus 0.064176, comma 0.2045 018. That is confidence interval for the difference in death rates comparing two cases. One case was natural or population in terms of the population, and comparing that with the tomb openers, basically. Okay. All right, folks, you did it. We are done with this chapter 2 and with this lecture. Now I'm going to start doing some problems from the book. And what we are going to do today and next week, I'm going to do problems. I was thinking that maybe I should start from the end of the book, like do some problems from chapter 23 and go backwards and see how far I can go. Because most of you probably have questions regarding the latest chapters. Is that the way you want it, or do you want me to start from chapter 1? Hello? Anyone there? So we'll go chapter 3 and backward, right? Okay, that's good. Backward sounds good. That's good, good, good. Starting on chapter 23. That's perfect. All right, let's see. I will put these questions. If you have, is this the one I'm doing? If do you have the do you have the questions? Everyone has the book, or do you want me to copy the questions and put them on Canvas? Everyone has a book or has access to the ebook, or copy them. Okay, we'll do it. I'll do copy. But today I'm going to show you this, and then after today I will copy them and put them on Canvas. Then you have access to that. All right, let's do these problems quickly. I'm sure you can help me. And here what we have. Let's read this problem. In 2012, respondents to the General Social Survey were asked, there are always some people whose ideas are considered bad, dangerous by other people. For instance, somebody who's against churches and religion. Somebody who's against churches and religion. Okay. If such a person wanted to make a speech in your city, town, community against churches and religion, should he be allowed to speak or not? He or she. Okay. So among the 573 male respondents, 459 said allow, whereas among the 719 female respondents, 552 said allow. Is there a difference between the proportion of males and the proportion of females who would allow an anti-religionist to speak? Okay, exercises 9 through 13 are based on these results. All right, let's go through this. Okay, take P sub M as a proportion of male, P sub F as proportion of female, to be the proportions of all males and females who would allow an anti-religionist to speak. The hypotheses to be tested are, okay, so it should be, you know that this is, all of them, they have the same thing. You know, the null hypothesis must be equal. So all these A and B and C, this part is good for all of them. But here at one point says difference, no difference. Didn't say somewhere difference, where was it? Male allowed, okay, is there a difference between the proportions? So that means when you say difference, that means P1 not equal to P2. Only answer matches with that is this one. So A is the right answer. Okay. Let's move on to the next one. The sample proportions of males and females who would allow an anti-religionist to speak are, so you got to find the ratio of these. Ratio of those is male and female. Let me see. Add a sheet to. Oh, it's here. Okay, so we have this is the male. So you have 459 divided by 530. Female would be, I'm looking at this here, look at the values here. This was a 459 out of male respondents out of 573. That's why I'm writing the ratio. And for the women is 552 divided by 719. And if you do this calculation, you get something Okay, for uh, for male, you get 0.801. For this one, you get 0.768. This would be again A. I thought the women's ratio would be higher, but it's not. Somehow I thought that women are more liberal than male. Females are more liberal, but in this case, they're not. Okay, men are more liberal. Okay, let's move on. Now, we're going to calculate this now. The pooled sample proportion of respondents who would allow an anti-religionist to speak is, so the pool, if you want to calculate the pool, what is it? So you have to have number of successes, that would be 459, plus number of successes in the second case, 552, divided by the total number, 573 plus 719. Okay, let's see what this number is. 11, 9, 10. And that one would be 12, 9, 12. And if you divide those two numbers, what do you get? You get, you guys can help me too if you have a calculator. I'm using my iPhone and do that. You get 0.78250,774. Okay. So which one of these answers is correct? 0.768, 0.78. Yeah, if you round this, this becomes 3. So B is the correct one. That is the pooled sample. Okay, we did that. Now let's look at problem number 2312. The z-test for comparing the proportions of males and females who would allow an anti-religionist to speak as which one of these? You got to calculate the p-value. It's not a kind of a simple multiple choice. That means you have to go through some calculations, which is going to be similar to final exam. I might give you something like this. You have to do some calculations and come up with the right answer. And when you do something like this, if you show your calculations somehow by mistake you mark down something wrong, if your calculation, what you did on your calculation, probably you will get partial credits. So the more you work, the more work you show, so the better grade you will get, basically. All right, let's do the z-value. Z-value is equal to the definition of z-value, p1 minus p2, divided by, we have to have a pooled value. We have them all there. 1 over n1 plus 1 over n2. If any of you have a calculator, you can calculate this quicker than I do. It would be greatly appreciated if you can help. So P1 hat is 0.801 minus 0.768 divided by P tilde, that would be 0.7831 minus 0.783 times 1 over N1 is 573 plus 1 over 719. Okay, we got to calculate this. Z is equal to, okay, the difference between these two, that would be 3, 3, 0. That's in the numerator. In the denominator, what we have here, this is 0.783. Okay, 1 minus that, that would be 7, 1, 2 times that. And 1 over 573 plus 1 over 719. We got to use calculator and do that. So let me just do this. I multiply this. I have that value multiplied by 0.27, 0.217. So I got, this is point. Oh, you got it? Thank you. Okay. Thank you, Nika. So that is 1.428, or approximately 1.43. All right. So we have 1.43. Now we have to use the table. And the table again, let's look at it. 1.43 is, we are using table A. This is 1.4. This is 1.4. And this would be, if you look at it, 1.3 would be 0.9236, 0.9236, 0.9236. For P, Z less than 1.428, that would be minus, what was it, 0.9206? 0.92, 0.9236. And is this difference? Yeah, difference we have to multiply by 2. Because this is going to be, we're calculating this. This is the Z star here. We got to calculate these parts. So either you have to say 1 minus this entire thing, it's going to give you this, and then multiply this by 2, you get the both of them. Or calculate negative of this, which is going to be here, negative of Z star. And then multiply by 2. Either way, we should get the same answer. I'm going to write the other one here. And if you do this, we get 1 minus that. That is 4, 6, 7, 0, that times 2. That would be 8, 2, 5, 1, 0. And this is equal to 15%. That is that much. You could have done this if you do this Z less than minus 1.428, you get exactly the same answer. You don't have to. All right. So what is this number? What is the answers? What was the question anyway? So we want to know here, the z-test for this, we would like anti-religionists. So our P is 15%. 15% is not this one. 15%, it's this one, C. 15% is greater than 10%. So the answer is C. Okay? Are we okay with this? Yes? No? Anyone is there? Everyone is gone? Oh, that was good. Good, good. Okay, let's continue then. Maybe we can finish this exercises today. But how many more minutes? I still have 15 minutes. I'm sure we can finish this. Okay, let's do this one now. It says the 90% large sample confidence interval for the difference PM minus PF sub F in the proportions of males and females who would allow an anti-religionist to speak is about this one. We got to calculate this, right? How do we calculate this? We have to, what are we calculating? So one way of doing this quickly, this is a good thing to look at it. You can see all of them, they have the same values, right? The only difference is here. You got to calculate the errors. If you can calculate the errors, it's going to give you one of those. That would be the answer. But anyhow, the difference, we calculated this difference too, didn't we? Here, remember that's a difference on the top, P1 hat minus P2 hat. So we have that difference. So for the confidence interval, let's write the formula. So you have P1 hat minus P2 hat plus and minus Z star times. And then we have, what is the formula we have for this? Wasn't it, you look at the formula. It's here. We're using this formula. So it would be Z hat, P1 hat, 1 minus P1 hat divided by N1 plus P2 hat, 1 minus P2 hat divided by N2. Okay. Our P1 hat is, we calculated, that was, if I'm looking at my notes, P1 hat was 0.801 and P2 hat is 0.768. And Z star is 90%. 90% is how much? I'm going to look at this quickly. 90% all the way down here is 1.645. 90% corresponds to Z is 1.645. So let's put the numbers there. CI is equal to 0.81 minus 0.768 plus or minus Z star square root of 0.801, 1 minus 0.801. N1 is number of males, it's 573, plus P2 is 0.768, 1 minus 0.768. Number of female is 1719. We put those values there, so we got to calculate this. CI is, this is 0.33 plus or minus. This is 1.645. So this would be 0.814 times. That would be 99. That would be that divided by 7573. I was hoping someone is going to calculate this quickly before I do it. And this would be 2320 divided by 719. All right, CI would be equal to 0.003 plus or minus. Let's do this calculation now. All right. So I have 0.801 times 0.199. That's equal to, so this is equal to 0.19399, and I'm going to divide this by 573, and I got this number. This entire thing is 0.00027818. I'll do the same thing on the other side. This one, 0.768 times 0.232, that's equal to that, 0.178176 divided by 719. So we have this number to be 0024781. So I'm going to add this one to the previous one, 327818, and I get this number. So I have this number, I'm going to take square root, I get this number, the entire number is 10005259901. I rounded up, so let's take square root of this, and I ended up getting 0.0229. Let's write those things. So CI is equal to 0.033 plus minus 1.645 times 0.0229. So if I multiply this by 1.645, so the final answer is CI is plus and minus. If you multiply that, you get 0.037727. I don't think we go beyond that. So the answer would be, let's see, what would be the answer closest? It's not point, it's this one. It's B, right? Because it's B, so it's 0.037. Yeah, if you round this, this becomes 8 point. Yeah, exactly. See that? It's the C. The answer is C, this one. Okay. Let's do, maybe we can do one more. In an experiment to learn if substance M can help restore memory, the brains of 20 rats were treated to damage their memories. The rats were trained to run a maze, a maze. After a day, 10 rats were given M, and 7 of them succeeded in the maze. Only 2 of the 10 control rats were successful. The z-test for no difference against a higher proportion of M group succeeds as this one. Again, we have to calculate the z-value. And we have to do the same thing that we did before. Let's do it one more time. A good practice. So you have z is equal to, you have p1 hat minus p2 hat divided by p hat 1 minus p hat 1 divided by n1 plus 1 over n2. Okay, p1 hat is, you're going with the first group. You can call one of them first group. It's 7 out of 10 was succeeded. P2 hat would be 2 out of 10 succeeded. One after taking n drugs, and the other one is not taking it. So you have those values. N1 and N1 is 10, N2 is 10 for both of them. We put all the values here. So you have 7 over 10 minus 2 over 10 divided by, you got to find P hat here. P hat is number of successes in both cases. That would be 7 plus 2. The number of the size of the samples. That would be 10 plus 10. This would be 9 over 20. 9 over 20 is 0.45. This is 0.7, and this is 0.2. Okay, so makes it easier to calculate these things here. So this is 0.7 minus 0.2. Down here, P is P hat P P. This should be P tilde, right? Okay, 0.45, 1 minus 0.45 times 1 over 10 plus 1 over 10. And Z would be 0.5 divided by square root of 0.45 times, this would be 0.55. And this would be 1/10 and 1/10, that would be 2/10. 2/10 would be 0.2. Let's do this calculation. So you have 0.45 times 0.55 times 0.2 is equal to, that is equal to 0.0495. If you want to take the square root of that, that is, the entire thing is equal to 0.22486. You have, now you got a 0.5 divided by that. I'm going to inverse that and multiply it by 0.5. And the answer is 2.24733. That is the Z value. Do we have anything close to this here? So the candidates, when you look at this problem, so we calculate the Z value, either it's going to be this one or that one, because that is 2.25, 2.25. So if you cancel 7 here, this becomes 5. So either one of this is going to be the candidate. But here, are we calculating, going to calculate the value of P now. And so higher proportion, again, it's going to be 1 minus PZ less than 2.25. This is what we are calculating, p-value. Sorry, I don't have any blank sheets. So this would be equal to 1 minus, you look at the table again, 2.25, 2.25, 2.25 here, 2.25, and that would be 0.9878, 0.9878, and this would be equal to 2210. So therefore, this is, the p-value is 12.2%. So this is the p-value, and we calculated Z is, and Z is 2.25. Which one matches with this? If you look at it here, so between these two, that's p-value. And Z value is, did we calculate it right? Oh, this is 1 point, I'm sorry. This is 1.2. So it's not this one, it is first A. A is the right answer. Because Z is 2.25, P is less than 0.02, because we got it as Z is less than point. This is like saying that 1.2. Because 100, that would come 1.2. 1.2 is smaller than 2%. This is a 2%, this is a 1.2%. So the answer would be A. Okay, we are done. We couldn't do the last two, so maybe next time. All right, I'll post these problems online. Thank you. Have a good evening. Good afternoon. All right. You're welcome.